So it says, if a loan is negotiated with a fixed discount rate D per basic unit of time, then for each $1 borrowed over 0t, the borrower walks away with 1 times 1 minus dt, and the loan is repaid by 1 at time t. So what I want to say here is that a fixed amount of discount per year or time period translates to D times T, meaning multiply by the number of years, just like you do for IT. You know how you go 1 plus IT in the case of simple interest? This time I'm talking about simple discount. So this would be 1 minus dt. So let me draw a diagram which will describe to you what is going on. Let us talk about time 0, time t, and let us say that $1 is borrowed. So remember that in the case of discount, the amount that you borrow is written at time t. And so we're saying that dt is the charge, and you will walk away with 1 minus dt. So if you borrow $1 at a discount rate D, you will walk away with 1 minus d times t, and that means that you owe $1 at time t. Remember this? It's similar to the other discount that we were talking about, the general discount that we were talking about when we had k, and then we had k times 1 minus d before, right? Okay, so obviously if this is not 1 and if this is k at time t, then you would walk away with k times 1 minus dt. And the charge would have been k dt. So you can see that this is k minus k dt. So the charge would have been k dt. So this is when you're borrowing k dollars. Notice that I put the k dollars at time t. So this right here is important. It's a fixed discount rate D per basic unit of time. So that means that the accumulation function A of t would be the following. This is t, this is 0. If I start with 1 here, this would mean that this accumulation function A of t would be 1 over 1 minus dt, because as I see here, v of t is equal to 1 minus dt. Right? I've said a lot in the last 1 minute. I'm saying that the discount function is 1 minus d times t. Therefore, the accumulation function is the reciprocal of the discount function. It would be 1 over 1 minus dt. So in this case, I first established that my discount function is 1 minus dt to get from here to here. And therefore, the accumulation function is the reciprocal of that, which is 1 over 1 minus dt. Are you with me? Yeah.
Actually, a quick question. On the very top where it says or time period equals, what is that? D, is that a division sign?
Here,
Yeah.
d times t.
Okay, thank you.
So if I were to draw this accumulation function, what would it look like? I want to draw A of t. What would this look like? Could I do this? Let's say that d equals 0.05. 0.05, suppose. So I want to draw a of t equals 1 over 1 minus 0.05t. It starts at 0.01 and then goes up. Is it undefined anywhere? Won't it be 20?
Yes, right.
20, right. So let us take this denominator and set it equal to 0 to see where this function would be undefined, right? So undefined at 1 minus 0.05t equals 0. So I'm setting the denominator equal to 0, and I get t equals 20. So at t equals 20, this thing is going to be undefined. And then I want to see where to start. So when t is 0, what is a of 0? Right, a of 0 is 1. So let's start at 1, and this function looks like this. It's only defined up to t equals 20. After t equals 20, this function would be negative. So it's not really defined as a of t, right? So I'm going to say here it's defined for t less than 20. Because after that, it would look like this, and that doesn't make any sense for my a of t function. Follow me? So vertical asymptote at t equals 1 over d. Let's write that. Vertical asymptote at t equals 1 over d, where d was 0.05 for me. And of course, this is the a of t for simple discount. Everybody okay with this? Yes or no? So I created this curve by just understanding where the vertical asymptote is. I know that a of 0 is 1, and I'm done. Any questions? No question? Let's move on. Compound discount. So compound discount has an a of t is equal to 1 plus I. We know that a of t is equal to 1 plus I to the t, and I know that 1 plus I is equal to 1 over 1 minus d. Remember, I have that relationship? So without much thinking, I can say that a of t is equal to 1 minus d to the minus t. Why? Because I have this relationship that says that every 1 plus I times 1 minus d is equal to 1. So 1 plus I is equal to 1 minus d to the minus 1. And therefore, if I raise this to the t, and I know that this is my a of t in the case of compound interest, then I raise this to the t also. And I'm done with my function. It's just 1 minus d to the minus t for this reason, because I have this relationship that says that every 1 plus I can be replaced by 1 minus d to the minus 1 power. Get it? So there's not much for me to do here. Just use this. Just go ahead and use this. Let's do an example. It says the annual effective interest rate is equal to 5%. Find the equivalent annual effective discount rate. Meaning I equals 5%, go find D. We know how to do this already, don't we? We have this relationship right here. So let's use it, this one. So I equals 0.05, D is equal to I over 1 plus I. We solved for this before. So D equals I over 1 plus I, just plug in 0.05 over 1.05. And let's see what this is. .05 divided by 1.05. And I get 0.0476. As we said last time, D will be less than I. And it is. So what is your question about this? Anything?
Is the D less than I always the case?
Yes. Remember we showed last time, or once, maybe 2 classes ago, that D is equal to I, 1 over 1 plus I. And since 1 over 1 plus I is always less than 1, D is always less than I. So I suppose I should write some rules here, right? Let's put it down here that if you start at 1, at time 0, the A of t is equal to 1 plus I to the t, which is equal to 1 minus D to the minus t. Finished. And therefore V of t is equal to 1 minus D to the t, because it's the reciprocal of the A function. Get it? Let's do the next example. How much money do you need to invest at time 0 in order to accumulate, this should say, to 5,000 at time 5, if we assume a compound discount 5% model? So the question is, at time 5, you want to end up with 5,000 using compound discount. How much is X? So let us use this V of t, because I want to go back, right? I'm applying a V of t here. V of t is equal to 1 minus D to the t. My t is 5. So V of 5 is equal to 1 minus D to the 5th power. I'm using this right here. So X is equal to 5,000 times 1 minus D to the 5th power. And you just clean this up. 5,000 times 1 minus 0.05 to the 5, which gives me 3868.90. 5,000 times 0.95 raised to the 5. 3868.90. So if you start with 3868.90 at a discount rate 5% compound, you will end up with $5,000 at time t equals 5. That's what this says. Question? Nothing? Everything is clear? Let's go to the next page. Alyssa wants to borrow money at an annual compound discount rate 7%. D equals 0.07. To purchase something for $4,500. She wishes to repay the loan in 4 years. How much must she ask to borrow? Okay. She wants $4,500 now. Remember, the ask to borrow, how much must she ask to borrow? That's written at time 4, right? That's the weird thing about discounts, right? This is the loan amount. So she wants to end up with $4,500 right away. This is the amount she must ask to borrow, K, and we're trying to find K. So, easy enough. What's the accumulation function in terms of D? Give me A of T in terms of D, please. What is A of T? Just look on the previous page, right? 1 minus D to the minus T, right? How do I know this? How am I going to remember this? Very simple. If A of T is equal to 1 plus I to the T power, every 1 plus I equals to 1 minus D to the minus 1. So just replace. Go through this step. Don't memorize. 1 minus D to the minus 1 times T. That makes it minus T. Finished. Don't memorize it. Don't memorize it. Just replace. Follow what I mean? Because how much will you memorize? Just replace every 1 plus I by 1 minus D to the minus 1 power. Okay, anyway, so I'm here and I'm going to plug in. So K is equal to 4,500 times 1 minus 0.07 to the minus 4 power. Which is 4,500 over 0.93 to the 4th. That gives me 4,500 times 0.93 raised to the minus 4. Bless you. 6015.62. So she should ask to borrow $6,015.62. What's your question? Everything okay with everybody? Next question. Is it better to borrow money at 5.1% interest or 4.9% discount? What should you do to answer this question? Yeah.
Would you convert like the discount amount to an interest rate?
Yeah. Exactly. How about convert this to I? How do you convert D to I? Do we have a formula that says I equals what? D over 1 minus D. Exactly right. Where does this come from? I equals D over 1 minus D. This comes from taking 1 plus I times 1 minus D and setting it equal to 1. Right? So I equals D over 1 minus D. So just go plug in 0.049 over 1 minus 0.049. This is going to give me 0.0515. 0.0515. So let's call this I2. I2. And I1 was 0.051. So it says, is it better to borrow money at 5.1% or 5.15%? Obviously, if you are the borrower, you want the lower interest rate. So the answer is I equals 0.051, meaning I1. We could have also changed everything to D. Instead of changing everything to I, the alternate method would have been to change the I to D. And of course, you would get the same result. So I should say here, note that if I1 is less than I2, then D1 is less than D2. Because 0.05 over, so let's say 0.05 is less than 0.06, which is true. So 0.05 over 1.05 will be less than 0.06 over 1.06. I'm doing I over 1 plus I. Okay? So note that if I1 is less than I2, then D1 is also less than D2. Let's go to the next part. Nominal interest rates of interest and discount. So it says many banks award interest more frequently than once per year. Example, monthly. They will advertise a nominal rate, IM, convertible M times per year. They are not actually paying you the nominal rate IM, effectively M times per year. They are paying IM over M, effectively M times per year. So what am I talking about? Let's see. Let's say that the advertised rate is I12, which is the nominal interest of 12% convertible monthly. So the superscript tells you how many times per year your interest is convertible. So my interest rate right here is convertible 12 times per year, meaning every month they're going to compound interest, right? Convertible monthly. That means that I12 over 12, which is 0.01 because it's 0.12 over 12, is equal to 0.01 per month. So this is 1% is the effective monthly interest rate. Are you with me? So when they say that the interest rate is 12% convertible monthly, like so, nominal interest rate 12% convertible monthly, this means it's a shortcut way of saying you better take this rate and divide it by 12 because you want to arrive at the monthly effective interest rate, and that is 0.12 divided by 12, which is 1% per month. And this is the rate that you would be using in all your calculations. If you try to use 12%, all your answers will be wrong. So why do they write it like this? they expect that when they say it's 12% convertible monthly, that the first thing you're going to do is convert that to a monthly effective interest rate of 1%. Follow me? Once you do that, you move on with your regular A of t function. I'll explain that in a minute. So it says here nominal interest rate convertible m times per year implies that the bank pays interest at an effective rate I over m divided by m per mth of a year. So we need the interest rate to be used in our A of t function. To be the effective interest rate. So A of t is equal to 1 plus I to the t, this I know, is equal to 1 plus I 12 over 12 to the 12t. Let me explain this. I need a timeline. So here's time 0. Here's time 1 over m, which is 1 over 12 because my m is 12. And here's time 2 over m, which is the 2-month period, 2 over 12. And at the end, I have m over m, which is 1, time 1. Now, I already know that if I had the effective annual interest rate I, if I started with $1 here, I would end up with 1 times 1 plus I, which is 1 plus I. Because my A of t function, this A of t, to go from here to here, is A of t equals 1 plus I to the first power, 1 plus I to the t. So in my case, it's 1 plus I to the 1, because I'm asking about A of 1, right? So now I'm interested in writing this A of t function in terms of Im over m. So let's think about what's going on here. I start at time 0 with $1, and then this $1 grows at 1%. So this little A of t here is 1 plus Im over m to the 1 power. So I end up with 1 plus 0.01. And then it grows again. This one grows again at 1 plus Im over m to the 1 power. So I end up with 1 plus 0.01 squared. And then do it again. And you end up with 1 plus 0.01 to the third. All said and done, when you get to the end, you are going to end up with 1 plus 0.01 to the 12th power. Are you following me? I'm saying that every month they're going to give you 1% interest. So 1 turns to 1.01, and 1.01 times 1.01 gives you 1.01 squared. And this process continues till you get to here, 1 plus 0.01 to the 12th power. So how about taking these two things and setting them equal? Set these two equal. So couldn't I say 1 plus I is equal to 1 plus I to the m over m to the mth power? So here I've used 0.01, 0.01, 0.01 to make it clear, but really what's going on is 1 plus I over m to the m, right? So at the end of the year, if I was using an annual effective interest rate I would have 1 plus I. And if I were using a nominal rate convertible monthly, I would have 1 plus I12 over 12 to the 12. Follow me? So I have the ability to set these two equal. And this is going to be our important formula that I use over and over again to convert, go back and forth between I and Im over m. So is there any confusion with what went on here? Please tell me right now. Maybe I can repeat it and you can ask me questions. I'm saying that if I have a rate which is I12, which is equal to 12%, that amounts to 1% per month. So if I start with $1, then at the end of 1 month, I have $1.01. Then this grows according to A of t. Let me write that. My little a of t is equal to 1 plus Im over m. And right here, so for the first month, I have 1 times 1 plus Im over m. That's just 1.01. And then again, so I'm going to write A of t for the monthly. So here, to go from here to here, I have 1 plus 0.01 times 1 plus 0.01. So at the end of 2 months, I have 1.01 squared in my account. And you keep doing that each month. So at the end of the year, you would have 1 plus 0.01 to the 12th power. Yeah.
Are all interest rates, like interest, I guess, available to be broken down like this? So like
Only if the interest rate is presented to you as convertible m times a year. So either they're going to tell you your interest rate is 12% annually, in which case I equals 0.12, period. Or they can tell you that the interest rate is I12, I superscript 12, which means that I12 equals 12% is to be changed to I monthly of 1%. So one way or the other, they will present it. And you can go back and forth between the two by using this formula. Follow? And it's not always monthly. They could say convertible quarterly, or convertible 3 times a year, or convertible 2 times a year, like that. Follow? Yes?
So, from going from 0 to, like, over the top to the accumulation function, the 1 plus I to the t,
Yeah.
would that I be point or 0.12?
Depending on whatever. No, it won't be 0.12 if your rate. Who's asking? So if your rate convertible monthly is 12%, that would be equivalent to an I annual of something different than 12%. So either this is 12, the top, or this is 12, but they won't both be 12. Right? Because when you convert it, it's not going to be equal. Actually, I is always greater than I12. Can you think of a reason why I would be greater than I12?
Because it is always increasing at like 1.01. It's always.
Therefore?
So if you start, like, if you think about the first month, if they both start at like 0.01, so if it's just like 12%, and you're just simply like getting the same thing at each month, then at the end of the year it will be like 12 times 0.01, then it goes to
Yeah,
Those for top month.
I agree with you. This one is getting compounded every month, so you can get away with a smaller interest rate and still arrive at the end result, the same end result. Do you follow? Because there's much compounding going on in between. So you can get away with I-12 being smaller than I and still end up with the same amount at the end of 12 months. Follow? The more you compound, the less you begin with, right? We know that. So if I were to compound 12 times a year, I could start with a lower interest rate than if I were compounding 2 times a year or 1 time a year, which is what we're talking about here. So she's absolutely right. Follow? Okay. So right now, can you tell me what this interest rate would have been? I? Can you solve for I? I'm asking you, what is I? I claim that I is bigger than I-12, right? And I-12 is 12%. So can you find me I right now? The annual effective interest rate, which is equivalent to 12% convertible monthly. Would you find me the I right now? So you're going to plug into this equation, right? Go plug. That's what I'm asking you to do. I'm asking you to say, if 1 plus I is equal to 1 plus I-12 over 12 to the 12th power, and I-12 is 0.12, I get 1 plus I equals 1.01 to the 12th. And therefore, I is equal to 1.01 to the 12th minus 1. How much is that? 1.01 raised to the 12th minus 1. So I is equal to 0.126825. So as we say, I-12 is less than I. Follow me? Any question? Okay. Let's go to the next page. I'm sorry? I'm sorry. So the next thing I want to do is convert 8% a year to a nominal rate convertible quarterly. Can you do it? I'm making this up. It's not in your notes, okay? How about I equals 0.08 is given. This is the annual effective interest rate. Find the nominal interest rate convertible quarterly. Four times a year I want you to compound. What's the equation, please? What's the equation? Can you give me an equation that I need to solve? Right. Do you agree with this? Okay. So 1.08 to the 1/4 equals 1 plus I4 over 4. Bring the 1 to the other side. 1.08 to the 1/4 minus 1 equals I4 over 4. Therefore, I4 is equal to 4 times 1.08 to the 1/4 power minus 1. What do we get when we plug this into our calculator? .08 raised to the 0.25 minus 1 times 4. I4 equals 0.0777. Notice that I4 is less than I. Again. Agree? Next page. Page 13. We consider the relationship between annual effective interest rate I and the nominal interest rate IM. We already know this from the previous page. We can move on to the next example. Perform the following interest rate conversions. Nominal interest rate I6. Look at this, they're going to convert 6 times a year, equals 12%. Convertible bi-monthly. Convert that to I. You're just going to plug in, right? And the next one. Annual effective interest rate I equals 6% to nominal interest rate I2, convertible semi-annually. So please try this at home. I want to work on the next example because this is nothing new. You should end up with I equals 0.12616 here. And here you should end up with I2 equals 0.059. I would like to do the next example because that's something different. Eric deposits $100 into a savings account at time 0. Eric. Time 0, $100. It pays interest at a nominal rate of I compounded semi-annually. So Eric, they're giving us a nominal rate compounded semi-annually. And then they're trying to be tricky. This is an old actuarial problem. They're trying to first call it I2, and then they're saying let that be I. So that's confusing because I2 is not equal to I in general, but they're saying let it be some I2, which they're calling I. Okay? So this is a poor problem in my opinion. But anyway, poorly worded problem for an actuarial exam. Anyway, so Eric's rate is a nominal rate compounded twice a year. Mike deposits $200 into a different savings account. Let's go here and talk about Mike. $200 into a different savings account at time 0, which pays simple interest at an annual rate of I. So Mike gets simple interest. Let's write that. Eric and Mike earn the same amount of interest during the last 6 months of the 8th year. Calculate I. So we're only interested in the interest earned. So let this grow, okay? Let's say this is times 7. I'm interested in the interest during the last 6 months of the 8th year. So the 8th year is the period between time 7 and time 8. And the last 6 months is the period between time 7.5 and time 8. So I'm interested in how much interest is earned in this half-year period between time 7.5 and time 8. And the same thing here, between time 7.5 and time 8. So one way to do this problem is to say that the amount of interest is just A of 8 minus A of 7, isn't it? Actually, A of 8 minus A of 7.5, because I'm interested in only the last 6 months. Could I do that? So could I talk about A of 8 minus A of 7.5 for Eric? And could I talk about A of 8 minus A of 7.5 for Mike? And then, of course, I have to remember that this guy starts with $100 and this guy starts with $200. So how about 100 times A of 8 minus A of 7.5 for Eric? And 200 times A of 8 minus A of 7.5 for Mike. Does that make sense? So what is A of 8 and what is A of 7.5 for Eric? Mind you, his rate is a nominal rate convertible twice a year. Can I do this? 100 times 1 plus I2 over 2 to the 16th power. I say 16th power because there are 16 6-month periods between here and here, right? So 1 plus I2 over 2 to the 16 minus 1 plus I2 over 2 to the 15th power. Could I do that? Certainly that's fair. Or I could cut to the chase and say, or start with the accumulated amount at t equals 7.5 and apply the proper interest rate.